Hello everyone, I am Sankalp, representing Team 2.ai, consisting of Kawai, Darren, Michael, and me. I'm going to present a technical brief on the ChattyISS chatbot for NUS ISS. Our objective for the ChattyISS chatbot is to address these gaps of the current NUS ISS chatbots. The delivery of the MVP is going to demonstrate the chatbot's capability of delivering accurate and up-to-date information. The following diagram illustrates the business flow for the proposed solution. As you can see, the administrative officer would insert documents into the folder in the network. At 12 a.m. sharp, the documents start being parsed separately by two subsystems. The documents are broken down into images and OCR is used to retrieve the text from the images. The second subsystem will generate a GPT model from the document. After this, the model is stored in the database as part of the knowledge base along with the original documents. Finally, when the user decides to send a query via the chatbot, the appropriate answer and a proof of image is returned back as a response. The concept for our approach to system design can be captured in the following flowchart. Firstly, we decompose the overall solution into its constituent subsystems. Next, we determine the primary requirements, assumptions, and metrics for each subsystem. After that, we explore potential solutions for each subsystem. And lastly, we recommend a specific solution for each subsystem and explain the reasoning behind it. Here, based on the system architecture, the system can be broken down into 6 main components. The first component is the front end, which represents the human-machine interface used by potential users of the systems, such as students or lecturers. Next, the backend endpoint represents the endpoint technology to receive and respond to queries from the front end. After that, the chat reasoning and knowledge base represents the core reasoning system for our chatbot system. Here you can see a detailed explanation of the knowledge and techniques required for chat reasoning. The user will first ask a question posed as a query. This query will go through pre-processing, which I will explain later, and be transformed into a word embedding. We then query our vector store that we have created, finding the top k relevant chunks based on their embeddings that are the most similar to the query embeddings. After retrieving the chunks, we feed both the query and the similar documents into the large language model, in our case, OpenAI's ChatGPT. This information will be included in a custom prompt template where we will get ChatGPT to generate our answer based on the query and the information given. Our knowledge base will store the knowledge for the reasoning system. The knowledge update module for document understanding passes the document into chunks of knowledge into the knowledge base. So here you can see a detailed overview where we load the relevant documents and pre-process them and split them into chunks. These chunks are then passed onto our word embedding model, creating embeddings which we will store in a vector store. Here we can see the knowledge update module for image understanding, which passes the document into several images, and each image is represented with words related to it. Here you can see a more detailed explanation where we use OCR to process the text data from the image. After the text is extracted, it can be converted into a vector-based embedding form to be used together with the main chat reasoning system. This is the final technological stack after going through the system design concept, which is illustrated in the diagram shown. The main users will be the lecturers and current or future students. We picked the Telegram bot or an embedded JavaScript chatbot for the NUS ISS website as our front end. Next, we decided to host a Python Flask server for REST API calls from the front end to the back end. We have implemented the system to run locally, and it can run in just 6 steps. Once the latest repository code is pulled from the GitHub repository, the user can simply enter in their API key at the relevant page. Next, the backend and front-end services can be started up, And once that is done, the chatbot is ready for use. In the backend service, there is a possibility to select which model to use in an admin page. To check how the bot runs on Telegram, the user can simply open the Telegram application on their phone or computer and search for the ChattyISS bot. Once the user has navigated to the bot, they can click and start typing questions for the bot to answer themselves. To test the embedded web page chatbot, the user can navigate to the locally hosted URL in their web browser and look out for the chat button on the bottom right corner. Once the user has clicked on the button, a chat window will open up and the user is free to ask whichever question they wish to. And here we have reached the end of our technical video. We hope you enjoyed it and thank you very much for listening.